Hello, my name is Rob Garner. I'm a computer programming instructor, and today I'm going to demonstrate how to use functions and also some string capabilities. So, to begin, we'll open up Visual Studio, and I'm going to create a new C++ empty project, and I'm going to call it string function demo and save it on my desktop. I'm going to add a new item, a C++ file, which we'll call string function demo. I'm going to add the standard items I need for a C++ program. We know we're going to be working with strings, so we'll add the string library. And we'll use the standard namespace. Some comments. And our main method for the program. We'll return 0 from the program to indicate we had good results. So the first thing we want to do is print a header. Well, we could just write out our header at the top with a bunch of cout statements, but since we do this a lot, suppose we wanted to have a function to do it. Well, we can do that by first declaring a function prototype. In C++, we have to define a function prototype at the top of our code before it gets called. And so we'll declare a function prototype at the top, and then down here below main, we'll actually define our function. So our function is going to be declared as a void function, which means it returns nothing. And it'll have an empty parameter list, meaning that it doesn't take any inputs. So in many ways, this is the simplest form of a function. And we'll display just a welcome message. And now I'll print out a little welcome message. In order to call our function, all we need to do is say print header. And what will happen is when we call the print header function, it will know what it is during the compilation, because we'll have described it ahead of time here for our compiler. It will then look for the code down below, and then when it actually runs, it'll run these three cout statements, and that's it. So let's try out our function. The nice thing about functions are that they kind of break up our programming. And since we want to be able to see this, we'll need to set our linker system, our subsystem to console, and let's try it again. And here we have our program, and we can see in main all we have is this call to the function, and the function is defined below, and it just does all this functionality and displays it. So this is a convenient way of making things that we reuse. And in fact, if you write anything that's reused, you definitely want to put it into a function. But even if you only use it once, it kind of breaks up the code, and it makes it easy to follow what goes on. And typically we'll put some kind of a comment above. So the next one we want to do is, let's say that we wanted to do the following. We want to get input from user, and then we want to show that text in uppercase, and then show the text in lowercase. So in order to do this, let's create some functions to do some of these tasks. The first one we want to create is the ability to get input from user. And so I'm going to define another prototype. And instead of void, I'm going to make this one a string. So in this case we have a single return value, and to define this function, it's actually easiest just to copy this. And we'll start off by declaring a string that will hold the text we get from the user. We'll prompt the user for a line of text, and then we'll use the getLine method or function to get that line of text. And unlike our void method, we need to return something, and the way we do that is we use the return keyword. Now when we call this, we're going to want a place to hold this string, so we're going to declare in our main method a string that we'll call text to convert. And we'll call our and the way we'll load text to convert is we'll just call our text from user method, and because it returns a string, it'll ask the user for input, get that line of text, return that line of text as a string from this function, and then that string will go into our text to convert variable. The next thing we want to do is we'd like to be able to convert things to uppercase. So we could write the code right there, but it's much cleaner and neater if we create another function. And so again, we're going to create another function. This is going to be a string function that's we're going to call convert word to upper. Or convert text to upper. And it's going to bring in a string called text, and it's going to bring a string called text, and it's going to return a string. So it's going to take this text, turn it to uppercase, and then return it. So I'm going to define the prototype above main, and then down below we're going to write our function that does the uppercase conversion. So I need a place to hold the result of that, so I'm going to call it result string. Or let's call it result text. And we'll initialize it to an empty text for reasons that will become clear later. And I'm going to declare an int I equal to 0. Well, I is less than text dot. And what we want to do is we want to go through each character of the text and convert it to uppercase. So we can do that by using the string class has a method called size, and that will return the size of our string. So if there's 10 characters in there, we'll return the size 10, and so this will cause us to go from 0 to just one less than 10, which would be 9. And since indexes in a string for characters is 0 based, this works just fine. And we'll increment I each time, so we go through character by character. And the result text, what we're going to do is we're going to use the plus equals operator, and we're going to use the upper function. And what the upper function does is it takes a character. You see it says int c, but that's really a character, and what it does is it takes its lowercase version and turns it into an uppercase version. And so we're going to take text, and one way you can get access to each character in a string is by just treating it like an array. And so what this will do is it'll take the I will point to each character in the array. So if you had a text that was 8 characters long, a string that was 8 characters long, then element 0 will be the first one, element 1 will be the second one, and so on and so forth. And so this will allow us to convert each character of resulting text to its uppercase version. And then all we're going to do is just return the result text. And then up here what we're going to do is, in our main, we're going to add another variable, and we're going to call it uppercase text. It's also going to be a string, and we'll just display that. Well, first what we need to do is we want to take uppercase text and set it equal to convert text to upper and pass it the text to convert. So text to convert we get the text from the user. The user inputs a line of text and it comes into text to convert. Then we pass that to convert text to upper, and then then we get uppercase. And we want to see that, so we'll see out and we'll output that. So we have enough to test at this point, so I'm going to hit Control F5, click yes. And we see that it asks us for a line of text. And we can see that it converted the whole thing to an uppercase. So how did it do it? Well, we came through, declared some variables in main, print the header, which did this function, called getTextFromUser to get the user texts. So it sent out that prompt, got the line of text, passed that into text convert. We passed the result of that into convert text to upper, and we put that in a variable called uppercase text, and then we just displayed it. So the nice thing of these functions are that it kind of breaks up your code and makes it easy to code in smaller chunks of functionality. So next, let's do a case which handles lowercase. Well, we can use pretty much the same sort of function as upper. So I'm just going to copy upper and just to redefine it. And all we'll do is we'll just use the lower function, and this should work the same. We'll go through and change everything to lowercase, and we'll kind of do the same thing here. We'll need lower case text. We'll call our new toLower function. We're still going to apply it to text convert that we receive from the user, and then display it. If I run that one, we see that we get the uppercase version and we get the lowercase version. You can see that the uppercase L was converted to lowercase. So now that we have our lowercase and our uppercase functionality, what else can we do? Well, we could see if we can find some text. And so we're going to extend our use case here. We're going to say, or user story here, and we're going to say we're going to get some an input from the user on what they want to search for, and we'll find and report the position of that text. And since I need user input, I can just reuse actually the same function I used before. I'll need a place to put the input from the user, so I'm going to call it text defined, and I'll declare it as a string as well. And I'm going to say text defined is equal to get text from user. So all I'm going to do is reuse this function again. And once we have that, we could write a function to find the text, but it turns out that string already has a function to do that. So we're just going to use an existing function. And we're going to declare an int called text location. And we'll set it equal to text to find. And if we search through the IntelliSense, we can see that there is a number of methods associated with the string class. In our case, we're just going to use this find one, and we're going to pass it. Well, actually, we don't want it. We want it to search within our text to convert, the text that the user put in before, and then we'll put in text to find. And what this does is this find method function here takes the text that is passed in as a parameter and it returns an integer pointing to where that text is located in text to convert. Now, if it finds it, it'll be in the regular number. If it doesn't find it, it'll return a particular value, and this value is something called the string endpos. So to use this, what we do is we say if text location does not equal string double-colon endpos, then we know that it found something. Else, if it is equal to endpos, then we know that it didn't find something. So first we want the condition that if it does find something, that meant that it does not equal this endpos result. And if it finds it, what we want to do is tell the user that they found text to find and text to convert, and tell them that they found it at text location. So what this does is it gets an input from the user, stores it in a variable called text define, which is a string, and then uses uses the string find function to see if that text that was put in from the user is in the original piece of text that they input. If it finds it, it'll equal some number, which won't be endpos, in which case we'll display to the user where we found it. If text location is equal to string ::: pos, then what we want to do is cout text not found. So this number here, and it's basically it's equal to the largest possible number or the largest possible value for pointer to a string, which we'll get into later. If it equals that, then that means that it wasn't found. And so we'll run this and see what it looks like. So line of text. We get our uppercase, our lowercase. Let's find something in our text. Let's look for the word of. And we see that it was found at position 5. If you think about this, large L is position 0, I is 1, N is 2, E is 3, this space is 4, and that and of is located at 5. So it found it. Now suppose we wanted to append something to the end of our text. Well, we can do that in the following way. We'll ask our user for some text to append, and then we'll display appended text. And we're going to ask the user much the same way we did before. And then, so this does the same thing as we did before. It prints out, displays a message, and then gets the input from the user. And then what we can do is display the appended text. And so what I'm going to do is take our text to convert, well, first we want this to be text to append, and we're going to have to declare that variable up here. And the neat thing about strings are we can just append. So the user types in some, we can just use the addition operator to append. So we're just going to get some input from the user, and then we'll just add it to the original text, and then we'll display it. If I hit Control F5, build it, we'll run through our program again. And then oh, we couldn't find it, so at least we've tested out our text not found capability, which works. Some text and some more text. So we see that this was added to some text, and we got the full appended text, so that also works. Now suppose we wanted to add some complexity into this, and let's say that we back up here in the find and report the position of that text. When we display it here, we would like to highlight the word we found by putting it in all caps. Well, we could do that, and what we're going to do is we're going to define another function. And this function, we're going to again create another function prototype and call it string convert word to upper. And it's going to, we're bringing in some text, and then we're going to bring in the position of the word that we want to convert to upper. So what this is going to do is take that text that we brought in, point to the word that we want to convert to uppercase, and then it's going to return a string which is going to have that one word made into an uppercase word. And so I'm going to add this function at the bottom, and it'll be a function to convert one word to uppercase. And so at this point we know that we have the position of the text location of the word found, and we know that we have the text to convert. So that should make this function call possible. But in order to do that, what we need to do is get the words before, everything before that word and everything after that word, and then get that word. So in order to split this up, the first thing we're going to do is get the first part. Then we're going to get the word. Then we're going to get the last part. And then we're going to return first part, comma, word converted to uppercase, and then last part. So let's try this first piece. And I'm going to need a place to hold the first part, so I'll declare a string. I'm going to initialize it to an empty string. And all I'm going to do is I'm going to use a for loop in order to go character by character and get all the characters from 0 to the position of the word. And since it's less than, it's going to stop just before it gets to that word. And then all I need to do is say first part. And we can find the location at a character of each character inside of a string by just treating it like an array, and we'll place an open bracket, I for the position of that character, which is going to start at 0, then 1, 2, 3, all the way up to just before the word that we want to look for begins, and then it'll finish up there. So that'll be the first part, just before, that'll be all the characters just before the word that will be placed in this string called first part. So we can try that out, and what we can do is call that function here so we can test it out. We're going to convert word to upper. We're going to pass it the text that we got in, and it's text to convert, and then text location. And we know this is safe because we already checked to make sure that there is a valid number for text location. Wrong function here. This needs to be convert word to upper. We already know that text location is good because we checked to make sure it's a valid number, and of course text to convert is whatever the user input. So I'm going to hit Control F5 and run it. And we're only doing the first part now, so And so we want to find word, and it finds it. And we can see that found word in testing word to uppercase at position 8. So it looks like we didn't completely do it. Found word, and we can see that it hasn't quite done what we expected to. Let's take a look at our code and convert word to upper. Oh, we had an error, that's why. And we didn't return a value. So down here we need to at least return, we're going to just return the first part and try it again. So I'm going to compile. Enter a line of text. And we can see that here, before it would display the whole message, now it's only displaying up to test, and then it looks like there's a space there. So it got the first part of our sentence. So we got test. Next we need to get word, and then we need to get the last part. So this is working so far. So the next thing we want to do is get the word. And the way we can get the word is, again, we need a place to store it. And we're going to declare an int I is equal to. Notice that we can redeclare I here because I is actually not in scope. When we declared int I here, it only exists within the context of this loop. Down here it doesn't. If I were to just put I would actually get an error saying I is undefined, because at this point I doesn't exist yet. So I have to actually declare I at this point. And I'm going to initialize I to position, so that's going to point to the first character of the word. And then while I is less than, and we want to go from, and we want to keep searching throughout this our text. And so I'm going to take text and use the size method or function, and what the size function of a string does is it tells me the number of characters in the string. So while I is less than the total number of characters in the string, and while text of I does not equal the space character, so this is a space. So what it's going to do is it's going to keep searching through until it either hits the end of the text or it finds a space, because what we want to do is we want to find this. When we find the space, we find the end of the string. That'll be the entire word. And what we're going to do is, as we go through each of those characters, is we're going to add those characters to our word variable. And so this is going to append word chars to our word variable. So this will go through from where the word begins all the way to where we find a space, and just keep adding those characters to our word variable, and the result will be that word will then contain that word. And so when we get done, by this time I should now be pointing at a space or the end of the text. So that gets me the word, and I'm going to add that to what gets returned. So now we'll get the first part of the text, plus the word. And I can test that. And this time I'm going to try to find the word find. We seem to be having a difficulty. We have an infinite loop here in this while. We actually need to increment I. So it got stuck in here. Try it again. And this is the advantage of trying things a piece at a time. So again, so we find at line 16, and we see that line of text to find, it got line of text 2 and then find, and so we can see that we're finding that word in there and that it's actually starting to concatenate this whole sentence back together, which we display up here. So the next thing I want to do is get the last part. And to get the last part, I is already pointing to either a space or the last element of the text. So what I can do is I can just keep using that variable. So I'm going to say while I is less than text.size, let's concatenate the rest of the characters onto that last part. And so what this is going to do is I is pointing towards possibly a space. If it's a space because there are more characters after that, then what will happen is it'll compare I to this size of text. If there's more characters, it'll go through each one and put that into the last part. If on the other hand there was only the word was at the very end, what it'll do it won't actually execute this, because it'll come to here, and if I is equal to the size, then this condition will fail, and last part will be basically an empty string. So what I've done here is I've taken the first part, I split it up so that I can find I've gone character by character, built the first part, take the characters that are associated with that word, take the characters that are associated with the last part, and then add them all together to rebuild our text. We're going to run this, and what we see is and then I put in blah blah, found blah blah and blah blah in this line at 5. So it finds it. This works pretty good. Now the next thing I want to do is I want this to become an uppercase, so I can actually reuse convert text to upper up here, this function that we already wrote. And so I'll convert text to upper, and that will make the word be uppercase. And you can see that now it displays that in uppercase. So I was able to find a word, convert it to uppercase inside of an overall line. Now one of the things that we often do is when we compare things, we will convert them to lowercase to make it insensitive to the whether or not something is upper or lowercase. And get that, what we could do is in here where we say text defined, we can actually do this string we can convert the text that we're going to search and then to lowercase, and we can convert the text defined to lowercase. And what this will do is it'll actually convert the things we're searching for and the things we're searching into lowercase, and so it will become insensitive to whether or not something is upper or lowercase. And so if we try that, did I redefine something? Okay, we had to change that to a new variable because we're already using it. So now I'm going to and then if I put it blah all lowercase, normally wouldn't find it because this is uppercase and it's not the same, but because we converted it to both to a lowercase before we did the find, it's case insensitive when it's trying to find the location, and it finds it anyway. So that's a technique that we also use sometimes. Finally, one of the things that we find in this is sometimes we get this signed, unsigned, these signed, unsigned warnings. And if you double click on those, you'll see that what happens is text.size returns an unsigned int. And what you can do is you can just, if you want to get rid of those warnings, change it to unsigned, and these will go away. It doesn't stop execution or change it from executing, but they do. It's not a bad practice to fix those warnings by changing our variables to unsigned so they match up with the methods which they're being compared against. And that completes my demonstration. Thank you.